Welcome to week 6 of BIM for existing buildings. Let's recapture what you have learned so far. So far, you should be able to identify and explain design errors that are typically propagated within a digital construction environment, and also the subsequent origins of such. You should also be able to define the clash report nomenclature, so the different types of clashes that may occur on any given project, as well as the typical clash management challenges and future considerations. In addition to all of the aforementioned, you should now have a better understanding and also a list of potential practice-based case studies to refer to within your own coursework reports. And all of these case studies that have been previously discussed lie within the confines of the development of an as-built BIM model for asset management or FM. In addition to such, you should also be able to discuss the way in which BIM can be utilized and operated in a collaborative manner in a federated environment. And what does a federated BIM environment mean for a potential facilities management team member? The pre-sessional activity for this week is to collate the data and information and begin to commence the work that seeks to determine how such data and information can be used to generate knowledge and intelligence for building operations and maintenance. So what does this mean? Essentially, we want you to be able to identify within the confines of an as-built BIM what specific data and information could be used to harness knowledge that's applicable in the confines of asset management and day-to-day operations and maintenance. Now, today's lecture is going to cover an overview of computational intelligent techniques that can be adopted, and also an example application of such computational techniques for building surveyors. And this will also include a discussion on the way in which robotics and the future practice of building surveying can be augmented through data-driven decision-making that is actually emanating from the use of computational intelligent techniques. So some of this work is going to touch upon the use of mathematical modeling systems for data-driven decision-making. The post-sessional activity for this week is again a reading material. Now, this research paper is suggested because it will provide the basis for next week's lecture. Essentially, this research paper touches upon the way in which one of the 7 digital dimensions, so sensor-based technologies, can be coalesced with as-built BIM models or BIM models in general. Although this is in an academic context and it's still a research-based exemplar, it is something that industry is more and more considering applying in the context of building management systems with the existing sensor-based monitoring systems that monitor electricity usage within buildings, for example. So use this research paper, although it's in the confines of an academic setting, as a way to develop your own ideas and conceptions of how sensor-based technologies could be used, if augmented with BIM models, to improve either asset management or operations and maintenance. And this should always be related to your consultancy report which you're developing for this module. The additional reading resource is the following research paper. Now, the reason for suggesting this particular paper is that it provides an example in a very different setting of mathematical modeling techniques or computational intelligent techniques applied within a BIM setting with a very particular purpose, in this case for the purpose of compliance. So use this as an exemplar to formulate your own ideas. Perhaps there are other applications in the FM sector for code compliance that may be augmented with an as-built BIM model. Once again, thank you for listening and thank you for your time.